Subscribe to AmpCode and ring the notification bell to get the latest content.
In the last lecture, we have seen all about the data frames and their basic operations. But data frame API and their transformations or operations are mainly used for processing the batch data. But here, let's start with the Apache Spark streaming concept, where with the help of streaming API, you will be able to process your data in real time. So your data could be coming from any real-time source. It could be coming from a sensor, it could be coming from website logs, it could be coming from anywhere else. It could be coming from any IoT device. So there are so many possibilities and so many data sources for which generates the real-time data, and the data could be coming from high volumes. So there comes the Spark streaming's distributed computing comes into picture. But here you have to understand that Spark is not an actual real-time platform. It processes the data in near real time. That is very important. And we are going to see in detail how it works under the hood and how it processes the data in just no time. So without further any ado, let's get into it. Okay, so let's jump into and learn about Spark streaming. So basically, Spark streaming is nothing but a very scalable, fault tolerant platform, and it could process the data in real time using the Spark ecosystem. So it uses Spark's whole architecture to process our data in near real time. So basically, Spark will get the data in streams and process them in very short batches, or we can say it as micro batches. So what is micro batches, that we are going to see in detail in the next topic. But here we are talking about near real-time analytics and getting the quick insights from your data. And that's why Spark will allow us to distribute our workloads. So if your data is coming at a high volume and at a high velocity, that also Spark will accommodate. So that is like a basic overview of streaming API. So you may ask why Spark streaming is really required. So if your data is very critical and coming at real time velocity and you need quick insights, many data driven organizations are leveraging their data to gain some quick insights into it. So if we talk about specific use cases like fraud monitoring, where you need active fraud monitoring. So if you talk about the credit card portfolio, let's say if a person applies for a credit card, and if a bank wants to detect any fraudulent activities in that credit card before approval, then in that case real time data analytics is the way to go. Also, there are so many scenarios where the decision making is the key factor. So let's say if you are searching for any product on Amazon, so they have the recommendation system which processes all the requests in real time and gives you the recommendation by checking your order history, by checking your search results and what's not. So in those critical applications where you need the quick insights, Spark streaming will help you to process the micro batches of the data. So there is the DStream, which is discretized stream. So DStream is nothing but represents real-time data stream, and we can do all sorts of windowed operations. So DStream is nothing but the real-time stream divided into smaller batches. So that is called the micro batch, and we call it as a DStream if we talk about Spark streaming. So basically, windowed operation will allow you to process your data and apply some transformation on the DStreams. So this is how you can process the data in real time. And also, one of the best advantage of Spark streaming is its compatibility and integration with different tools and technologies. So Spark streaming can seamlessly connect to Apache Kafka. So Kafka is also a pretty popular tool to process big data in real time. Also, it can work with Apache Flink, Kinesis, and there are so many platforms which processes the data. So you can utilize Apache Spark streaming for data ingestion utilizing all these platforms. So if we talk about another very good feature of Apache Spark streaming is its stateful computation. So there are like many traditional data processing frameworks which doesn't allow it. So this stateful computation is really helpful if you are applying any aggregation operation. So it will get the state for each batch of data and gives you the aggregated output. So it is, so if you want to get the count of all the responses you received in last 1 hour or maybe a 1 day, then you can get that aggregated output if you talk about Apache Spark Streaming because of these stateful computations. That also we are going to see when we kick off and build our first Spark Streaming application. And if we talk about like the use cases of Spark Streaming, there are so many. The first one is real-time analytics. So if you want to check your website traffic of what is going on, what is trending. So if you want to get meaning out of your website traffic to see all the trends, also the social media analytics and so on. So for that purposes, Spark Streaming is a good option. It is also a good option if I talk about the fraud monitoring. So if you are building any fraud monitoring dashboard to see the spikes of all the anomalies and also get the hidden meanings inside your data. So for that purpose, Spark Streaming is also a good way to go. Also, if you talk about the IoT devices like applications like the smart cities, the healthcare department, there are so many applications which requires the real-time analytics and to get a quick peek into your data. And like fraud monitoring and healthcare department has some really critical applications which only relies on the real-time decision making. So for that purpose, Spark Streaming is a great option.
So that's it for today. I'll see you in the next lecture.